Okay, this first question here is a tricky one, and make sure you read it correctly because it tells you that they did a flame test and a bright yellow flame was seen, but they know that this sample contained those two ions. So how could we prove it contains those two ions? Sorry. So the best way of doing this would be to do flame photometry. Use a flame photometer. And what you would end up with if you did that, a more accurate way of measuring this, is you would end up with two sets of colours forming. And all you'd have to do is match them against reference samples. 2 marks in there. Use photometer, and you should get two colours forming. It's going to give you the marks. Okay, this question here is produce an ionic equation. So if you remember, what we've got to do here is split this up into ions. So H plus and Cl minus, Na plus carbonated Cl3 2 minus. Over here you've got Na plus and chloride ions. Carbon dioxide is covalent, so it doesn't have any ions in there. And the same goes for water. H2O is covalent, so there's no ions in there. Okay, so to get the marks in this question, all we've got to do is remove spectator ions. They're ions that are the same on both sides of the equation. So for example, I've got Cl minus and Cl minus. I've got Na plus and Na plus. So what am I left with? I'm left with here two H pluses, a CO3 2 minus. This whole just slide across a minute. This whole compound here is gone. So all I'm left with on this side is CO2 and H2O. CO2 and H2O. Marks for this are 3 marks available. So if you got the formulas right, you get 1 mark on each side, and if you've got the balancing right, you get yourself a 3rd mark. Okay, last little bit. What we have to do here, again, a lot of information, so please take time to read it. And again, this question is not straightforward in that they want you to say that none of the conclusions are fully justified. So explain the points that are justified, and then what further work would be needed to justify the conclusion. So if you have a look at substance K is, we get a white precipitate, which is fine with silver nitrate because this contains chloride ions, and therefore we expect a white precipitate. With the sodium hydroxide, we get a colour solutions being formed, but that doesn't prove that it contains ammonium ions. So what we have to do then is, to prove it contains ammonium ions, you would warm the test tube with the sodium hydroxide in, and then any gas that is being produced, you test it using damp red litmus, because we'd expect ammonia to be produced, and the litmus therefore would turn blue. So the first bit is explaining what's good, second bit is what else needs to take place to prove the result for substance K. Same approach for L. So again, we get a white precipitate because we know it contains chloride ions, and that's with the silver nitrate test. We get a white precipitate with sodium hydroxide, which suggests it contains aluminium ions, but they could also be calcium ions. So to fully justify it, you add more sodium hydroxide, and this white precipitate should dissolve to give a colourless solution, proving it contains aluminium ions. And the final one, so We get a green precipitate with sodium hydroxide. That shows it contains Fe2+. There's no precipitate formed with silver nitrate, which is what we'd expect, therefore it's not a chloride. But if we add hydrochloric acid and barium chloride, we should then get a white precipitate because it would contain a sulfate ion. So that's proving that the positive result that would need to take place. Now I've counted up there the 17 bullet points. So again, to help you get the marks, use the table here to generate the marks and give yourself a total for question 10.